Hi students. In the last lecture, I have discussed spherical mirrors, and in that we have learned center of curvature, radius of curvature, pole, principal axis, focus, focal length, and paraxial rays. Okay, let us now continue. So now in this, I am going to discuss sign convention. Let us consider a concave mirror. And this is now principal axis. And we are taking the principal axis as x-axis. Let us take this principal axis as x-axis. Suppose object is now real. Object is real. This is object. Light rays are traveling towards right side. They travel right side. So we are taking now direction of instant light rays as positive. So now in this, instant light rays are traveling towards right side. So we are taking the pole as origin, right of the pole as positive x-axis, left of the pole as negative x-axis. So here sign convention is direction of instant light rays is taken as positive. Now in this problem, light rays are traveling towards right side. Therefore, right of the pole is positive x-axis, left of the pole negative x-axis. Okay. For example, mirror is like this. This is now principal axis. We are taking it as x-axis and take a real object. This is now object. Now in this, light rays are traveling towards left side. Towards left side. That means we are taking now left of the pole. Left of the pole as positive x-axis. Right of the pole as negative x-axis. So understand carefully. Direction of light rays, in this case, right side. That's why right of the pole as positive x-axis, left of the pole as negative x-axis. Coming to here, light rays traveling towards left side. Therefore, left of the pole is positive x-axis, right of the pole is negative x-axis. Okay. Now here we are taking U, V, F, and R. These are coordinates or x coordinates of object, image, focus, and center of curvature. I am repeating. These are x coordinates of object, image, focus, and center of curvature. Let us see now the signs for this. Okay. If you see in this case, object is real. Object real means light rays are diverging from that point. So here light rays are diverging. It is real object. According to our sign convention, this is now on negative x-axis. Therefore, U will be negative for real object. So I am writing here U negative for real object. Okay. If you see here, again same. Light rays traveling towards left side. So left of the pole is positive x-axis. Object is now on negative x-axis. Again same. U negative real object. Now see meaning of virtual object. Virtual object means we have discussed in the beginning. If a converging beam is falling, if a converging beam falls on the mirror, we can see here. So converging beam falling on the mirror. If you extend these rays, now they will converge at one point behind the mirror. See carefully. This is now converging beam. A converging beam falling on the mirror, and they are traveling towards towards left side. So according to our sign convention, left of the pole is a positive x-axis. Now they converge behind the mirror, means on positive x-axis. Now that point is acting as object. It is virtual object. That means U is positive for virtual object. So U negative for real object, U positive for virtual object. So virtual means converging beam falls on the mirror. Okay. Next. Now focus image. Now this is mirror. For example, focus here. If light rays are really converging after reflection. So here, if you consider, if you assume that if light rays are really converging after reflection, then that will be a real image. And you can see they are really converging means on they converge in front of the mirror. That means they converge on negative x-axis, right? So this is now a real image. So whenever rays are converging after reflection, they converge in front of the mirror. That means they converge on negative x-axis. Therefore, U, sorry, it is V, right, for image. It is V. So V is negative. V is negative for a real image. For real image. Suppose I'm taking here, let us take instant rays traveling towards right side. Let us say after reflection, they are diverging. That means like this. After reflection, they are diverging. Now extend these rays back. After reflection, they are not converging, they are diverging. We extend those rays back. Where they converge, that is now virtual image. And you can see here, rays are means instant rays traveling towards right side. Therefore, right of the pole is a positive x-axis. Left of the pole is negative x-axis. That means V is a positive for virtual image. For virtual image. Okay. So now see, U negative real object, U positive virtual object, V negative real image, V positive virtual image. Okay. Next, coming to focus. See how to decide now coordinates of focus. So first of all, if you want to know the location of focus, so we have to consider a parallel beam, means parallel to principal axis. So here we focus only per axial rays. If we consider parallel beam, means parallel to principal axis, after reflection, these rays are crossing the principal axis at one point, and that point is now known as focus. That is known as focus. And you can see here, this is now meeting, or you can say crossing the principal axis in front of the mirror. That means on negative x-axis. So whenever we are taking parallel beam, means parallel to principal axis, they cross the principal axis in front of the mirror, means on negative x-axis. That means F. F is negative for concave mirror. F is negative for concave mirror. Let us consider now convex mirror. Consider convex mirror. This is now principal axis. Now consider a parallel beam, which is a parallel to principal axis, incident on the mirror. You can see after reflection, these rays will diverge. I am taking one more light ray here, instant lattice. Now they are diverging after reflection. Okay. Now extend those rays back. Okay. This is now point of divergence. Or I can say this is a point where they converge. If we extend them rays back, this is now focus. And you can see instant light rays traveling towards right side. This is now pole. Right of the pole is a positive x-axis. Now, this is a focus, means which is behind the mirror or which is on positive x-axis. That means F is a positive for convex mirror. So I hope you got a clarity regarding sign convention. Okay. See, once U negative real object, U positive for virtual object, V negative real image, V positive virtual image, F is negative concave mirror, F is positive for convex mirror, right? Let us see once. So real object U negative, virtual object U positive, real image V negative, virtual, or it is virtual image V positive. Okay. Let us now focus relation between U, V, and R. Relation between U, V, and R. Relation among U, V, and R. Okay. Let us see how to get it. First, consider a concave mirror. Now take principal axis. Principal axis. Let us take object. Let us take object here. O stands for object. Now light rays are incident on the mirror. Let us draw once again. It is light rays are incident on the mirror. Instant beam. After reflection, after reflection, now they are passing like this. Let us draw normal at point of incidence. Normal means it must be passing through center of curvature, right? Let us take this is now center of curvature. This is now center of curvature. So draw normal at point of incidence. Right, this is now center of curvature. Let us take this instantly makes angle. It is alpha, and this is now beta, and this is gamma. This is now pole. Let us take this is now A. Okay. And take here angle of incidence, that is psi. Angle of reflection also same, right? It is equal to I, because I equal to R. Let us see carefully. Let us take now this is A. Take it as this is B, and this is C. C stands for center of curvature. Now take here triangle OAC. So taking triangle OAC. See in that what we can say, alpha plus I plus, you can see this angle 180 minus beta, so plus 180 minus beta, that is equal to 180. So sum of the angles in a triangle equal to 180. See carefully, alpha, this is I. This angle is now 180 minus beta. Now from this, see what we can write. Alpha 180, 180 gets cancelled. Alpha plus psi is equal to beta. So equation 1. Now consider triangle. See triangle now. It is O, A, and I. This is now image. What is it taking as B, right? It is triangle O, A, B. So in this triangle O, A, B. See now what we can write. This is alpha. Next O, A, B. I and I. Total is now 2I. So alpha plus 2I. Next. And you can see this angle 180 minus gamma plus 180 minus gamma. Cross check once. Alpha. This is now 2y. And this is 180 minus gamma. Total equal to 180. Now in this 180 gets cancelled. Alpha plus 2y is equal to gamma. Equation 2. Okay. Let us now simplify this. So in this, we want to eliminate now angle of incidence, because the relation among U, V, and R is not depending on angle of incidence. It is for any angle of incidence. Okay. So we want to eliminate now I. So then what we can do is, in the place of I here, I am writing beta minus alpha. Okay. From 1, I am writing, I am taking 1 into 1 in 2. So alpha 2 into, in the place of phi, beta minus alpha. Beta minus alpha. See, where is this? 2 into I. In the place of a beta minus alpha, that is equal to gamma. Okay. Now simplify this. Then see what we get. Alpha, it is minus 2 alpha. Okay. So from here, what we can write? 2 beta is equal to 2 beta is equal to alpha plus gamma. See carefully. This is 2 beta minus 2 alpha plus alpha minus alpha. I have taken that to right side. Okay. So we got here 2 beta equal to alpha plus gamma. Now see how to get the values of beta, alpha and gamma. We can see here, if I am drawing one normal from point A to the principal axis, if we consider these angles alpha, beta, gamma are small, when they are small, this point will be very close to point P, means very close to pole. Okay, that means when we are taking here tan alpha equal to approximately equal to alpha, that is equal to tan equal to opposite side by, that is now AP upon it is OP, because this point is very close to pole. Okay, it is now AP opposite side by, it is OP. Okay, in the same way tan beta, since beta very small, approximately equal to beta, that is equal to again AP by CP. It is AP upon CP, right? Next, tan gamma. Tan gamma equal to approximately equal to gamma, that is equal to AP upon BP. Okay, BP. Now substitute these values in this equation. In the place of beta, AP by CP. Right? In the place of alpha, AP by OP. In the place of gamma, AP by BP. Throughout, AP gets cancelled. remaining is now 2 into, in the place of beta, after cancelling AP, it is 1 by CP. 1 by CP. That is equal to, in the place of alpha, AP cancel 1 by OP. 1 by OP plus, in the place of gamma, 1 by BP. Right? And you can see from diagram, value of CP. CP means it is now radius of curvature. So the length of CP is now radius of that mirror, right? Sorry. This mirror is now a part of a sphere, right? So CP is now radius of that sphere. Okay. So CP is now R. So CP value is R. Next, OP value. What is OP? Distance of the object from pole. Okay, OP is now distance of the object from pole. BP. This is now image. Distance BP stands for distance of image from the pole. But remember, we have given the condition that U, V, and R, they are coordinates. Okay. And according to our sign convention, see light rays traveling towards right side. Therefore, right of the pole, positive x-axis, left of the pole is negative x-axis. That means these coordinates are negative. U is negative, V negative, R is negative. Okay. But here CP, it is a distance, right? It is radius of curvature. OP, distance of object, again distance, that must be positive. BP, it is again distance of image, it should be positive. So here what we are doing is CP. CP equal to minus sum. OP equal to OP. OP means minus U. Next BP. BP equal to minus V. Do one thing to understand. I will take one example here. This is mirror. Let us say distance of object. Let us say distance of object is a 10 centimeter. Okay. For example, radius of curvature is now, take it as this distance equal to, take it as 5 centimeter radius of curvature. Suppose this is image. Distance of image from the pole, let us take it as 4 centimeter. I have just taken values randomly here. Okay. In fact, we have taken values according to the condition which we are going to get. Okay. Just to understand, I am taking values, getting it. Distance of object to 10 means, see here, u value will be minus 10. U value how much? Minus 10, right? What is now distance of object? Minus u, because that gives plus 10, right? Distance of object. If they ask like what is v? Distance of image is 4. Therefore, v is now negative. Okay. V negative. So distance of image is minus v, because v value is 4. Sorry. V value minus 4. Because these are on negative x-axis. Their coordinates are negative, but we want distances, and distances can never be negative. Okay, that's why if r is 5, so r is not 5. In this case, in this case, okay, so we have taken distance of object is a 10. Then what is u means minus 10. If you want a 10 distance of object, we should take minus u, because minus u gives us 10. That is what I have taken here. Okay, minus r, minus u, minus v. Okay, now simplify this. Right. So finally, let's see what we got. Substituting those values. 2 upon in the place of Cp minus r, that is equal to 1 by in the place of OP minus 2, in the place of BP it is minus V. Okay, that means finally what we got, 2 by R is equal to 1 by V. So this is V, right? Let me correct it. It is V. So plus 1 by U. Okay. 1 by V plus 1 by U. And if you remember, in previous lectures, we have derived one condition, that is F equal to R by 2 for per axial rays. That means this is 1 by R by 2, that is 1 by F. So 1 by F equal to 1 by V plus 1 by U. Okay. This is known as mirror equation. Okay. So even though we have derived this for concave mirror, it is for both concave and convex mirrors. Okay. Just we have to follow proper sign convention. Right. So in the next lecture, we are going to discuss about magnification.